This section is about classifying the strength of materials. That may sound really simple, but there are a lot of ways that we can define strength. If we look at like a concrete, okay, you can build a building out of concrete and steel, but if you stress concrete in the wrong way, it will it will break, it will fracture. What is stronger? Is it a steel beam that or a concrete block? Is it a concrete block that can support a lot of weight until it fractures, or is it a flexible object that can flex with stresses and in that way support a lot of weight? Or is it not even about uh, stretching or not stretching? Can buildings be structured so that well, we know that buildings can be structured so that they sway in the wind or in an earthquake. Is the fact that it's swaying or flexing, does that make it stronger or weaker? So we have different ways we can define strength. And when we're talking specifically about materials, engineers will choose those materials carefully, and they have to define strength in a specific way for their specific product. And sometimes they'll make trade-offs. Uh, so some materials may weigh more but give more strength, and maybe they don't want that weight. Some materials uh, may be stronger but increase the cost. It would be great to have a carbon fiber bicycle frame, but maybe you don't want to pay for that. So there are a lot of these are trade-offs. So trade-offs are when you have to make a sacrifice to get an advantage in another area. So let's look at a few different designs or a few different materials. For each of these designs on the left side, we need to figure out what the most desirable material is. We have a list of materials on the right side, and we have to ask, okay, all these materials are strong in different ways or have different strength properties, but which ones are most appropriate for the design choices that we have made? So this is why it's important to define your criteria before making a design, before selecting your materials, before designing your product. Our first design is a lightweight prosthetic leg for a runner. Well, if you are running, you have to consider a couple of things. You have to consider the weight, right? So, and you have to consider the strength and the size. A prosthetic leg can't be too large, but it needs to be strong and light. So the best choice there is carbon fiber. Carbon fiber has good tensile strength, but it's brittle and it has a high strength to weight ratio. So it can have a lot of tension on it. That's good tensile strength, but it is brittle, and so legs should not be subjected to a lot of blunt force. So that's a good choice for a prosthetic leg, carbon fiber. How about a wearable anti-ballistic vest? That's like a bulletproof vest for maybe the military or police. Well, in this case, look at our choices. In this case, you're going to want a synthetic aromatic polyamide material. Oops, there we go. Because it has high tensile strength, and it's also reasonably lightweight. It's made of tightly connected chains that are hard to separate. This is what Kevlar is. It's plastic meaning um, it can flex. It's strong, and it's fairly light. It's not as light as, say, carbon fiber, like you would want on a leg, but it's light enough that you can wear it on a vest and carry it around. The tensile strength can be greater than that of even steel wire, and it has low compressive strength. Okay, so that's a disadvantage of it in certain applications. Our next our next but our next design is posts to support two floors of a home. And here we have two options. We have B, which is concrete, or F, which is steel. Concrete is good. Concrete has great compression strength and lower tensile strength. You can push on it, but if you pull on it, it will break more easily. It also has limited shear strength. So if you're building a house is going to be pushing down on the concrete. That's it's going to the concrete is going to support the house. On steel, on the other hand, steel also has good compression strength, but it also has good tensile strength and shear strength. It's made of iron and carbon alloy. Steel is more expensive than concrete and probably uh, more difficult to use. Um, Concrete, you can just mix it up, pour it in place. Steel needs to be fastened in different ways. It's not super difficult to use, but it's very useful. But it's more expensive. So but the advantage to steel is that it has more shear strength. So if you're talking about a home that might be in a hurricane area, or where there's going to be or an earthquake area, maybe you want to consider steel. Maybe it's worth the extra cost because the house may be moving laterally more than more than a house in an area where there's just compression on the posts. For our last option, a cushion for hospital bedding, the best choice here is E, polymer foam. Polymer foam has high elasticity. That makes a nice cushion, right? It'll bounce back. You can lie down and it'll bounce back. Well, not bounce back, but it'll return to its original shape. It has low tensile strength. You can't pull on it. But who's going to be pulling on a hospital mattress? And it's tough in compression. That means it can sustain a lot of